Okay. So we were discussing the graph theory. We have started. Okay, some basic definitions in graph theory we have discussed so far. Okay, discussed was the graph, subgraph, then path, connected path, okay, closed path, then also discussed tree, what are branches, what are links, okay, how many links will be there, okay, basic loop, and what are the non-basic loop. All right, six things were discussed in our previous lecture. Okay, now we shall continue from that. Hmm. So up to whatever we have discussed so far, do you have any questions? Anybody having any questions?
Sir,
Huh?
sir, বলছি, can you please move up a bit that page?
Let me see whether somebody is trying to join or not. Yes. Okay, please. Bolo.
স্যার ওই নাম্বার, স্যার একটু উপরে যান একটু। স্যার ওই নাম্বার অফ লিঙ্কসের ওই ইকুয়েশনটা বুঝতে পারিনি।
Number of links, তো
হ্যাঁ
এটা
হ্যাঁ,
আচ্ছা। So what
ওটা
is
নয়,
the
ওর
number?
উপরেরটা, ওর উপরেরটা, নাম্বার অফ লিঙ্কস ইন আ গ্রাফ, এটা কি?
Number of basic loops we have written. Number of acha. Number of elements in a tree. How many branches will be there? There is a number of elements. You see that here there were altogether 7 elements or 7. Right?
Yes, sir.
This, you see that graph here, original graph. This is the original graph. Here 1, 2, 3, 4, 5, 6, 7 elements and 4 nodes. Okay.
Okay.
Network branches are called graph of the elements. So 7 network branches here. Obviously, a current source with parallel impedance is considered a single branch because practically current sources are associated with parallel impedance. Okay, that's why this is considered to be a single branch, and corresponding to this, to represent this, we have drawn one element here, element number 3. All right, so altogether there are 7 elements. How many nodes? 1, 2, 3, 4. So in the tree, how many elements are there? 1, 2, 3 elements. So, and 3 elements are called branches. So there are 3 branches. There were 7 elements, and in the tree there are 3 branches.
Okay, sir.
Okay.
Okay.
So total there were 7. Now there are 3. How many are left? Those are the links. So 7 minus 3 equal to 4 are the links. Okay.
Okay.
All right. So number of elements in a tree is number of nodes minus 1, 3. Okay. So number of links in the graph means number of elements, number minus number of elements in the tree is the total number, means number of branches. And what is the number of branches? Number of branches means number of nodes minus 1. So if you put here, ultimately you will get the total number of links in terms of the number of elements, number of nodes, and number of nodes and number of elements. Now it is in terms of number of elements and number of branches. I think this is now clear.
Yes, sir.
ঠিক আছে? So, and then if that is clear, now number of links in the graph means number of elements minus number of branches, means number of branches mean number of nodes minus 1. So if you put it here, it becomes number of elements, say E, number of nodes, say N plus 1. So this gives you number of links or number of basic loops. Why number of basic loops? Because in each basic loop there is only one link. That is how the basic loop is defined. In a basic loop there will be only one link, and remaining elements of the basic loop will be the tree element, means branches. Okay. So
Okay.
in terms of the number of links or number of elements and number of nodes, we can determine how many will be the number of basic loops. So the E minus n plus 1n, number of basic loops are that number of loops which are to be written, equation for which are to be written to solve a network. So how many loop equations are to be solved? That will be equal to number of elements minus number of nodes plus 1. Okay, this is the number of loop equations you have to write to solve any network. All right. So you see that I have mentioned that writing network equation in graph theory becomes straightforward. It is very simple. How it is simple? For nodal analysis, it is not a problem because you can identify the nodes easily. Because all node will be taken as reference. So if you identify the node, reference node, the remaining nodes are already identified. So you can write equation for them very easy. But identifying the loop is somewhat difficult, particularly for large network. Okay, so how to identify? You have to form a tree first. Say this tree you have formed. As soon as you have formed the tree, then these are the links already identified. So you have to just choose a tree. So and choosing tree also is very simple because trees are to be selected in such a way that it includes all the nodes of the graph, but there should not be any, no, there must not be any closed path. So you simply have to connect the nodes with each other by an element that is required to form a tree. So as soon as you form the tree, you see that links are already determined. These are the links determined, and for each link there will be one basic loop. So you join one, you'll get this basic loop. Join element number 4, you will have this basic loop. Join element number 6, you will be this basic loop. Join element number 7, you will be this along with 7 as the basic loop. So loops are also identified as soon as you are identifying a tree. That's why identification of loop is very simple in case of graph theory. Okay, so writing loop equations are also very simple. So writing network equation in graph theory becomes a systematic process, step-by-step process. You simply have to follow the steps, and the remaining will be very easy. Writing loop equation then will be very easy. Is it clear? Is it clear? Any question?
Yes, sir.
Anybody making any question? So now let us come to another issue, that is the card set. Okay, just one thing. Then I have to okay, card set. Let us define this first. A card set. So you have the nodal analysis. For nodal analysis, you have to select a node as reference, and you have to for nodal admittance matrix. How to form the nodal admittance matrix? We shall see. We shall discuss later on using graph theory how it can be done. For loop analysis, first of all, you have to identify the loops. How that can be done? That is discussed here. You have to form the tree. So links are already formed, therefore, as soon as the tree is formed. So then the loops are identified. You can now form the network equations. Now consider the card set. Using card set, we shall see that we shall have another scope for writing network equation using another type of variables, which are branch voltage variable. Okay, so let us define a card set for that purpose. So let us define it. A card set is a set of minimum number of elements which, if removed from the graph, divides it into two connected subgraphs. That means you have to select a number of elements, select that number of minimum number of elements which, if you are removing from the graph will be divided into distinct two sections. Okay, those elements will be called the card set. That means in a card set, you will have a number of elements together. You will have a set of elements together. You have to remove those elements from the graph, and after removing those elements, if you see that the graph that was there is being divided into two sections. That means if those net elements are removed, then two sections of the network will be left. Okay, if this happens, then those elements together will be called a cut set. Okay, so let us give, first of all, let us see this with the example, then it should come here at this position. Okay, now let us consider that graph we have considered so far. Okay, so already this is the tree we have identified. So as this tree is identified, this is these four elements are the links. Now let us select a set of elements such that if I remove those set of elements, then the graph will be divided into two subgraphs. So what I can do, I can say remove 1, 2, and 4. So for this graph, let me remove 1, 2, and 4 and see what happens. If these three are removed, say how I am drawing the graph, say I have drawn the node first, 1, 2, 3, 4. Then I have joined the elements between the nodes. So in that way, if we form the graph, and if I remove element number 1, element number 2, and element number 4 from this graph, you see that node 1 will be left here, and on the other half, these three elements, these four elements, along with the nodes will be left. 3, 5, 6, and 7. That means this section will be left here. In the other section, only node 1 will be left. So that means a subgraph, may be formed by a single node also. Okay, if there is a single node, that also is a part of the graph, and that single node may constitute a subgraph. Okay, so if I remove 1, 2, and 4, then a subgraph is then the network is divided into two subgraphs. In one subgraph, there is only one node, node 1. In the other subgraph, there is element 3, 5, 6, and 7, along with the associated nodes. Is it clear? So we can say that 1 to 4 together is a cut set. Is it clear? It may be confusing for some people because the definition of cut set is like this, and it may sometimes create confusion in you. So you see whether this is clear or not, because identification or understanding which elements together may form a cut set, that is important. Then only we can apply that in network, writing network. So is it clear? How element 1 to 4, removal of these three elements together, is dividing the graph into two connected subgraphs. In one subgraph, there is only one node, is node 1. In the other half, there are four elements, 3, 5, 6, and 7, along with the nodes 2, 3, and 4. Okay, is it clear? বলো, any confusion?
স্যার এটা কাটগুলো ইকুয়াল কি করে হচ্ছে?
হ্যাঁ, কাটগুলো
ইকুয়াল কি করে হচ্ছে?
ইকুয়াল নয় তো, ইকুয়াল কেন হবে? Into two connected subgraphs, we should divide into two.
Oh,
two connected subgraphs. That means in one subgraph, there may be 5, 6, 7, 10 elements depending on the network. In the other half, there may be only a single node, or maybe there are more number of elements and node together. In this particular example, if I remove these three elements together, not one at a time, that means I shall have to remove all the three. Then only there will be node 1 in one half. On the other half, there will be 3, 5, and 6, 7. These four elements along with the nodes. This is the situation.
স্যার তাহলে তিনটে কাট হয়েছে এখানে?
আমি আপাতত একটাই বলছি, আপাতত একটা কাট সেট বলছি। সে I am removing 1, 2, and 4 together. All these three elements I shall remove. I shall extract from this graph. Okay. Then, if this is true, if you could understand that, you see that if I remove 1, 2, and 4 together, these three will be removed together from this graph. So what will be left? 1 will be left, and this node 1 will be left. In the other section, this element, this element, this element, and this element will be left. And when these elements are here, this node, and this node are also here. That means I have simply removed these three elements from this graph. And because of that, since I have done that, this is the subgraph that is remaining here. Node 1 is also there. And node 1, as per the definition of the subgraph, that may constitute a single constitutive subgraph, because only one node also may constitute a subgraph. So in this case, removal of 1, 2, and 4, these three elements, has divided the graph into two connectors. Am I clear?
Yes, sir.
Okay, now you see that what are the other subgraph positions. Also here note that if I remove only one, will the graph be divided into two sections? If I remove only element one,
no sir,
it will not be divided. The remaining is one section. If I remove
পুরোটাই একটাই কানেক্টেড থাকতো, মানে
পুরোটাই
একটাই
একটাই connected, পুরোটাকে একসঙ্গে remove করতে হবে। If you remove any one or any two from this, then you see that the graph will not be divided into two sections. So what are the minimum number of elements to be removed? It is 3. Therefore, these 3 are the minimum number of elements to be removed to divide the graph into two connected subgraphs. That's why 1, 2, and 4 together is a curse set. 1, 2, 4 together is forming a curse set for this reason. Is it clear? Now consider the other cases. Now also what we can do, now you see that why I have removed 1, 2, and 4, because I shall form the basic curse set. That means I could do other way also. What I could do, I could remove 1, 3, 5, 4. Let us check. 1, 3, 5, 4. If I remove, that means I am drawing a line. Why I am drawing a line? By drawing a line, I shall have a situation where that line is cutting some elements. Those elements will be removed. That's the purpose of drawing this line. Say I am drawing a line like this. That means I shall be removing 1, 3, 5, 4. What will happen? If 1, 3, 5, 4 are removed, then in one section there will be elements 6 and 7. Okay. In the other section, there will be 1, 3, 5, 4 are removed. In the other section, only element 2 will be left. Okay. I am removing this one, this one, this one, this one. So 2 will be left in one half. On the other half, 6 and 7 will be left. All right. That means in that case, that also is a cut set, because that these 4 elements together is forming a cut set. But this cut
not
set
minimum.
Basic cut set. It is minimum but not a basic cut set. Why not a basic cut set? Because in basic cut sets there can be only one tree branch. Okay, in the basic cut set, then we shall see. We have not defined this yet. Basic cut set, there will be only one tree branch, not more than one. So here the only one tree. In this case, there are two branches. So though 1, 3, 5, 4 is a cut set, that means if 1, 3, 5, 4 are removed together, then a cut set will be formed. But this will not form a basic cut set, because 3 and 5, there are two tree branches. That's why we are not identifying these two, this 1, 3, 5, 4 as a basic cut set. But if I select the lines to be 4, 5, 6, and 7, that means if 4, 5, 6, 7, these 4 elements are extracted, these 4 elements are removed, then what happens? Then you will have 1, 3, 4 in one, 1, 3, 2 in one section. In the other section, you will have node number 3 left. Okay. In this case, we can say 6, 7, 6, 5, 4. 4, 5, 6, 7. These 4 elements together is forming a cut set, or is forming a basic cut set. Is it? Am I clear? Would you understand? Everyone, please try to understand this, because unless you can understand it properly, you cannot actually, you'll be in a confusion and you cannot proceed further related to cut set discussion. Okay. That means if I remove 4, 5, 6, 7, these 4 elements at a time from this graph, then in one section I shall have node number 3 and I shall have on the other half 1, 3 and 2. Maybe this appearing to be a confusing situation to you, that you may think that how I am removing 5, 4, 6 and 7 together without removing node number 3, is not it? That may be the question some of you are thinking. Is it clear? Okay, some of you may be thinking that how shall I remove these 4 elements without removing the 3? We can remove because we are assuming that nodes are separate entity, elements are separate entity. As if these 4 nodes are installed first and then one by one the elements are joined to form the graph. Okay, so under the situation you see that obviously we can remove 4, 5, 6, 7 with node number 3 left here. Okay, then removal of these 4 elements together will create a situation where node number 3 will be left here as a subgraph. Elements 1, 3 and 2 will be left on the other section, forming another subgraph. So these 4 elements together is forming a curve set. Am I clear? And this is also a basic curve set because this is having only one tree branch number 5. Is it clear?
স্যার
বলুন।
স্যার মানে ফার্স্ট লাইনে তো বলা আছে এখানে মিনিমাম নাম্বার অফ এলিমেন্টস, তো যখন আমি ওই 1, 2 আর 4 কে করছি তখন তো 3টে এলিমেন্টস রিমুভ করছি, কিন্তু যখন 3টাতে মানে যখন 4, 5, 6, 7 এটা রিমুভ করছি তখন তো 4টে এলিমেন্ট রিমুভ করছি, তো দুটোই কাটছে তো।
হ্যাঁ, হচ্ছে মিনিমাম নাম্বার কোন সেন্সে বলা হচ্ছে, অর্থাৎ now you try to remove say element 4, 5, 6 together without removing element 7. So if I remove 4, 5, 6, these 3 elements, keeping 7 here, then what happens? Then this is a connected system now. You have 7, then 3, 1 and 2. Only one section. In the other section, there is nothing. It is void. Okay. So to separate this node from the remaining part of the network, you have to remove 4, 5, 6, 7. Then 4, 5, 6, 7 are the minimum set of elements to isolate this node from the rest of the network. Okay, unless you remove all these 4, that means these 4 are the minimum number of elements to create a separation between node 3 and the remaining part of the graph, means 1, 2 and 3, this section. Okay, that's why this is the minimum number of elements. If these are removed from the graph, then the graph will be divided into 2 sections. Am I clear?
Yes, sir.
মানে এখানে হচ্ছে এর মানে এখানে হচ্ছে ওই দুটো যে সেপারেটেড মানে ওই দুটো যে সেপারেটেড ওই সাবগ্রাফের ওই রেসপেক্টে মিনিমাম, তাই তো?
ওই সাবগ্রাফের রেসপেক্টে মিনিমাম টু ক্রিয়েট দিস সাবগ্রাফ। ওকে,
হ্যাঁ হ্যাঁ ওটাই। হ্যাঁ,
অলরাইট। নাও consider the other. Only we have shown only these 3. You see that if we remove again 1, 3, 6, 7, what happens? If we remove 1, 3, 6, 7 again, the situation is such that node 4 is left here and element 2, 5 and 4 left on the other section. That means again the graph is being divided into 2 connected subgraph with node 4 left here and element 2, 4 and 5 left at the other section. So again the graph is divided into 2 connected subgraphs. All right. And here in this case 1, 3, 6, 7, these are the minimum number of elements to create a separation, to create an isolated situation for graph node number 4. So these 4 will constitute the curve set, not a combination of or not a subset of these 4 elements. That means if you remove 1, 3, 6, you see that it is not isolated. You remove 3, 6, 7, then only not isolated. If you remove 6, 7 and 1, not all, that is also not isolated. That means you cannot remove any of these 4 elements from this group to isolate this network from the remaining part of the network. So to create an isolation, you have to remove all these 4 together. Otherwise, there will be no separation created between the 2 sections of the graph. That's why now 4 elements are the minimum number of elements to form this cut set. Okay, is it clear now? All right. Any
Yes, sir.
question, anybody? So you said that we have basic cut set 1, 2, 4. Okay. Now this definition I have not completed reading out. So let us explain each and every word written here. So a cut set is the set of minimum number of elements which, if removed from the graph, divides into 2 connected subgraphs. Okay, it is clear. Now cut set having only one tree branch is called the basic cut set. Okay, that's why we have selected 1, 2, 4 at the basic cut set. We have selected 1, 3, 6, 7 at the basic cut set because this is only having one tree branch. It is having only one tree branch, and selected 4, 5, 6, 7 at the basic cut set because this is having 5 as the tree element. No other elements in this cut set actually is a tree branch. That's why. Okay, but we have not chosen 4, 2, 3, 6, 7. These can also, if I join all these 4, that we draw a line like this to indicate that this line has cut a number of elements. Those elements can be removed to create two subgraph. Obviously, two subgraphs will be created if you remove 7, 6, 3, 2, and 4. Okay, obviously it will be created, but that will not constitute a basic cut set because that will have element number 2 that is a branch, element number 3 that also is a branch. So these elements 4, 2, 3, 6, 7, they cannot form a basic cut set. They will form a cut set but not a basic cut set. All right, am I clear? Similarly, if I removed 2, 3, 5, you see that then if 2, 3, 5 are removed, then what happens? Then this node is divided into, you see that you have node 2 left here and the remaining except 2, 3, 5 are left in the section. Then in that case, it will not form a basic cut set because it will be cut set, but not a basic cut set because all of them, 2, 3, 5, they are tree branches. So they are, this is not satisfying the condition that there will be only one tree branch. So that 2, 3, 5 together is a cut set, but not a basic cut set. All right, is it clear? Now, number of basic cut set is obviously equal to the number of tree branches. So obviously, if in each cut set there will be only one tree branch, so how many basic cut sets may be there? That is equal to the number of tree branches. Okay, that should be clear. A direction can be assigned to each basic cut set, which is assumed to be the same as that of the tree branch forming the basic cut set. Now, what we can do, as we have selected the cut set, now see that we have assigned a direction to this cut set. We have drawn a line here to indicate that this line is cutting a number of elements. So these 3 elements together is forming a cut set, and we have shown an arrow here to indicate that the cut set formed by this line. How formed by this line? Because this line is intersecting a number of elements. All those elements together is forming a cut set. So if I choose a direction here, that is indicating the direction of the total cut set. Okay, so I can choose a direction here. I can assign a direction here. How that direction will be assigned? It will be such that it is same as the direction of the tree branch. That means direction of this branch that has formed the cut set. Basically, we can say that this tree branch is mostly responsible for the creation of this cut set. We could choose other elements also together to form a separate cut set, but we are choosing this one because these set of elements are having a single tree branch. So you can say that the reason for the selection of these elements of the basic cassette is element number 2, which is the tree branch. Therefore, direction assigned to this tree branch is considered to be the direction of the cassette. That's why this is the direction of the element, or this is the direction of the branch, tree branch. Therefore, this is also the direction of the cassette. How they are same? You see that this cassette actually moves as if this branch actually moves from the left side of this line to the right hand side. So direction of the cursor is also considered to be the from left to the right of this line. That means arrowhead is towards the right, arrowhead is towards the right. So this indicates the direction of the cursor, same as the direction of the tree branch forming the cursor. Am I clear? Is it clear? বুঝতে পেরেছ? Or still having some confusion here? It means I shall have to choose the direction that is necessary. Why? That will be clear later on, because I shall have to represent the cursor. There I shall assign a direction of the cursor, because otherwise I cannot actually move to right network equations. So for that I have to assign a direction to the cursor. So how to assign the direction? It is assumed that direction of the cursor will be same as the direction of the tree branch. You may ask why I am choosing so, because I have to assign a direction. So I have to follow a convention. I shall follow this convention. That is the reason. Okay. All right. So the convention is that the direction of the tree branch forming the cursor will be chosen as the direction of the basic cursor. Now, this direction and this direction are identical. In what sense? In the sense that this line is as if direction of the line is from the left to right of this line I have drawn. Again, direction of the cursor will be from the left to right of this line. So this is indicated by drawing this arrow. Okay. Is it clear? Or any confusion? Who are having any confusion? Please tell me. Bolo. Or everybody could follow, or nobody could follow. Bolo. Anyone who could follow? Is it clear, or shall I proceed? Let us explain this for the other cursor also. Then it may be more clear to you. Okay. Say I assign a direction to this cursor. This cursor is actually shown by drawing this arc. You may draw a line, you may draw an arc like this. What is the purpose of drawing this arc? Because this arc is actually cutting these elements, indicating that all these 4 elements are to be removed together to form a basic cursor. Okay, this is the purpose. Now, direction of this cursor, that means direction of the cursor formed by the combination of these 4 elements, has to be chosen. What will be the direction? What has to be the direction chosen as given here? It will be same as the line or same as the branch that is there in the cursor. So in this cursor we have element number 3. This is the tree branch. The direction of this tree branch will be the direction of the cursor. What is the direction? This line is cutting this arrow in this way. That means it is from the top to the bottom, or it is from the left hand side of this arc to the right hand side. So I am also assigning a direction from the left hand side. You are standing on this arc, so it will be on the left hand side of the arrow to the of this arc to the right hand side. If you stand on this arrow, on this arc, sorry, you'll see that it is from left to right. So if I stand on this arc here, the direction of the cursor also will be from the left to right. Okay. Similarly, if I consider this cursor, then this is the direction entering towards the node. That means again from left to right of this arc. So I shall have to choose the direction of the cursor as left to right on this arc. Okay, this is how the direction has to be chosen. Now you see or tell me whether you could understand this or not. Or any question here? Bolo.
স্যার ডিরেকশন স্পেসিফাই
Direction? বলো।
ডিরেকশনটা স্পেসিফাই করাটা ইম্পর্টেন্ট কেন একবার একটু বলবেন?
হ্যাঁ, ডিরেকশনটা স্পেসিফাই করা ইম্পর্টেন্ট বিকজ later on we shall actually represent this mathematically. We shall write equation finally. While we write the equation, we have to include the direction as well. Because direction basically is to indicate the positive direction of current. Okay, there you have to choose a convention that this is the positive direction of current. All right. Therefore, you have to choose some arbitrary direction as the positive direction. Here we are choosing this arbitrary direction as the positive direction because just one. Okay. Okay, excuse me. Okay, so the purpose is to assign a positive direction to the current. Okay, to the quiescent current. So for the quiescent current, we are assuming that the positive direction will be the direction of the tree branch that is included in the quiescent. Okay, that is the purpose of assigning a direction. All right.
Yes, sir.
So shall I proceed?
Yes, sir.
Now you said here this whatever I have discussed here, that is written here. Okay, I think you will be now in a position to understand this. I have discussed everything. Now, if these are actually understood, now let us come to again to the loop, basic loop. Okay, what is the basic loop? I think that set is clear now. Let us come back to the basic loop. Okay, you see that if you consider this, it will be better if we draw. Okay, if you consider that this is the tree. So you see that if I join element number 1, then a loop is formed. This is called a basic loop because in this loop, that is 1, 2, 3 together is forming a loop that will be called a basic loop because in this loop there is one link only. Similarly, if I join element number 4 with the tree, then this basic loop will be formed. 2, 4, and 5 together will be formed. This is a loop and this is a basic loop because in this loop, element number 4 is a link and remaining elements are tree branch. Okay. Since there is only one tree branch, since there are only one link and remaining elements are tree branch, that loop is basic loop. That is how we define basic loop. Okay. Similarly, if I join element number 6 with the tree, then 3, 5, 6 together will form a loop, and that again is a basic loop because in the basic loop, these two are tree branches, this is the link. If I join 6, then another basic loop will be formed where 3, 5, 7 is the loop, and 3, 5 are the tree branches, 7 is the link. So this is one basic loop. 1, 2, 3 is a basic loop, 2, 4, 5 is a basic loop, 3, 5, 6 forming another basic loop, 3, 5, 7 forming another basic loop. In these 4 basic loops, why they are coming? Because there are 4 links in the tree. So how many loop equation are to be formed? Equal to the number of basic loop in the system. So now since we are coming to we are discussing the loop equation, again we shall have to assign some direction for the loop. Okay, as we have assigned some direction for the cut set, we shall have to assign a direction to the loop also. What direction we shall assign to the loop? For the loop, since in the basic loop there is only one link, let us choose the direction of the loop to be same as the direction of the link forming the loop. Okay, say 2, 3, 1. This is a basic loop. Then we assume that direction of loop current will be along the direction of the link branch. That means this will be the direction of the loop current. It will be clockwise because direction of element number 1 is like this. So if I assume this is the direction of loop current, then this is the direction of the loop current is same as the direction of the loop. Similarly, in the loop 2, 4, and 5, I have to choose the direction of loop current as like this. It will be anti-clockwise. You see that now while we are discussing graph theory, while we are discussing the loop current direction using graph theory, then we are not restricting to that requirement of forming loop equation in general terms when we have discussed that we had considered the loop current direction to be all clockwise. Here we are not doing that. Here we are choosing the direction of the loop current to be same as the direction of the link forming the loop. Okay, we have to follow some convention. This convention we are following. What is that? Why you are following this convention? Because that helps us in forming the network equation in a step-by-step manner. That's why, as I have chosen the direction of the link, and link is basically forming the basic loop because there is only one basic loop in the link. So if I choose the direction of the loop as same as the direction of the link, then I have a defined direction. I have a non-confusing direction. That's why I am choosing the direction to be same as the direction of the link forming the basic loop. So for this loop, for this basic loop, direction of the loop means direction of the loop current will be 2, then 5 to 4. That means anti-clockwise direction like this. Similarly, for this loop 3, 5, 6, here 6 is the link. So direction of loop current to be considered is anti-clockwise along the direction of element number 6. Okay, the same direction element number 6. So if I select this as the direction of the loop, then current is actually anti-clockwise. Similarly, in the loop 3, 5, and 7, I have to choose again an anti-clockwise direction because that has to be the direction of the element number 7. Okay, so here the difference with the loops that we have formed previously while discussing the loop current technique, there all the loops were considered to have positive current direction, clockwise current direction. Here, that restriction is removed. What will be the direction of the loop current? It will be the same as the direction of the link forming the loop. That means current direction now need not be same. It need not be the clockwise direction. It may be clockwise in one loop, it may be anti-clockwise in the other loop. Okay, could you follow this? Okay, that is written here. Okay, regarding the direction of the basic loop. So is it clear to you how direction of the basic loop is selected, how direction of the cassette is selected? Any question, any confusion, please tell me. Bolo, could you understand? Or who could understand, who could not, and who could? Bolo.
ইয়েস স্যার স্যার একটা জিনিস এখানে মানে এখানে যে কাট সেটের যে ডিরেকশনটা আমরা যে ঠিক করছি তো এখানে এখানে যে নোট হচ্ছে ওই 3 তে তো হ্যাঁ তো ওখানে যে ডিরেকশনটা আমরা যদি হচ্ছে ওপর থেকে নিচের দিকে না দেখিয়ে মানে এই দিক দিয়ে যদি যে দেখাতাম মানে
এখানে তো হ্যাঁ দেখাও, এখানে দেখাও। এখানে দেখালে কি হবে? ফ্রম দ্য রাইট হ্যান্ড সাইড অফ দ্য কি বলবো, এদিকে দাঁড়ালে, এদিকে মুখ করে দাঁড়ালে, তাহলে এদিক থেকে এদিকে হবে। একে মানে somehow it has to be same as the branch number 5. It is as the branch number has cut this arc, the same way the direction mark also has to cut this
ওই কার্ভটার হচ্ছে লেফট থেকে রাইটে যেতে হবে, মানে যে আলটিমেট ব্যাপার এটাই।
আলটিমেট ব্যাপার। আমি যদি এদিকে মুখ করে দাঁড়াই তাহলে লেফট থেকে রাইটে যেতে হবে। ওকে, আমি যদি উল্টো দিকে মুখ করে দাঁড়াই তাহলে কি হবে, এই দিক থেকে এদিকে যেতে হবে। হ্যাঁ, তুমি কিভাবে মুখ করে দাঁড়াচ্ছ তার উপর ডিপেন্ড করছে আর কি। ওকে
ওকে স্যার।
হ্যাঁ হ্যাঁ
স্যার স্যার বলছিলাম স্যার ফার্স্টের ডিরেকশন গুলো কিভাবে অ্যাজিউম করলাম, মানে একদম প্রথমে মানে
একদম প্রথমে যখন
মানে
যখন গ্রাফের ডিরেকশনটা অ্যাসিউম করছি, then it is arbitrary. You can choose the direction of an element as you want, but if once you choose the direction, once you assign a direction, you must maintain that throughout the process. You should not, or you must not change the direction in the mid, somewhere in the middle of the process. Okay, it has to be maintained every time. Okay, একবার ঠিক করছো তো এটাকেই ধরে থাকতে হবে, এটাকে বেরোবে না। ক্লিয়ার?
হ্যাঁ স্যার।
All right, is it clear? Now
ইয়েস স্যার।
this, what we have done, we have drawn a network graph. Okay, then we have defined some subgraph, defined path, then we have drawn a tree, we have identified the link, then from that we have actually identified the basic loops, we have identified the cut set. Okay, so for writing network equation, these are the things we shall need, we shall have to understand. Now what we shall do, we shall now represent this graph, represent loops, represent cut set mathematically using mathematical relations. Okay, somehow we shall have to represent this, because unless you write some equation you cannot solve the network, you cannot define the determine the network variables. So you have to write some equation. That means drawing this will not help you alone. If you draw this, then you have to represent this using some mathematical formulation. Okay, let us now do that. Let us now represent the graph with the help of some mathematical notation. Okay, and that therefore will be done using some matrix. We shall use some matrix to represent the network graph. We shall use matrix notation to represent the loop, also matrix to represent the cut set. First of all, let us write, or let us create a matrix called the node 2 element incidence matrix. So all this will be the incidence matrix. Incidence matrix means a matrix associating one element with the other, one thing with the other. In the node 2 element incidence matrix, so sometimes simply the incidence matrix, okay, or sometimes nodal incidence matrix. This is how it is actually referred to. Sometimes it is a node 2 element incidence matrix, sometimes people call it nodal incidence matrix. Okay, this is nothing but the association between the node and the elements. We shall represent here the association between the node and the element. That means if I represent the association between the elements and the node, what we are doing, basically we are representing, or we are describing the graph. Okay, so this graph is drawn here. This graph is this graph is drawn here. So with the help of node 2 element incidence matrix, we shall actually represent this graph with the help of a matrix. That is the essence of the node 2 element incidence matrix. Okay, how we shall form this matrix? But it's very simple. We simply understand the process and we will see that is applying graph theory is very, very simple. Now say how to form this network matrix or node 2 element incidence matrix. Here number of source of the matrix will be equal to the number of nodes of the graph. Okay, number of nodes, number of row will be equal to the number of nodes, and number of column will be number of elements, because it is node 2 element. How many rows equal to number of nodes, how many elements, how many columns equal to number of elements. Okay, That means number of row will be equal to number of nodes, number of column of the matrix will be equal to number of elements of the graph. Then an element will be, if graph is the node, say matrix is A, say a particular element is written as Aij. That means ith row and jth column of matrix A is written as A small a ij. Ith row and jth column of this matrix A, Aij. Element is Aij. It may have an entry equal to +1, it may have an entry equal to -1, or it may have an entry equal to 0, 1. So value of Aij is either +1, -1, or 0. When +1, if jth element is incident to and oriented away from ith node. Note here, is a jth element corresponding to column. Jth element is incident to and oriented away. That means incident to means jth element is connected to ith node. If there is a connection between jth element and ith node, means if ith node is a terminal of jth element, then there will be some connection. See, that means if ith node is a terminal of element j, and if the direction is such that, okay, it is away from ith node, then entry will be +1. Okay, entry will be -1 if jth element is incident to, that means jth element is connected to node I, or node I is a terminal of jth element, and direction of the element is towards node I. In this case, it will be -1. That means if the direction is towards the node, entry will be -1. If the direction is away from the node, it will be +1. And if there is no connection, obviously connection entry will be 0. Okay, no connection means entry will be 0. Connection is there and direction is away, entry will be +1. Connection is there, direction is towards, entry will be -1. Okay, now let us see what happens. Say we are forming this matrix. Say consider element number 1. In the row number 1, it is -1. Entry is -1. Let us understand this. Say element number 1. What happens? Actually, it would have been better had I drawn it near the matrix I have drawn. I have written. So element number 1. You see that here. Element node 1 is a terminal of element number 1. So Aij will have a entry either +1 and -1. Now
Directed toward -1.
towards means minus. Okay, and what will be the entry corresponding to A41? 41 means node number 4,
It
element
will be
number
the
1.
+1.
It will be +1. So let us check this. Okay, you see that this is here it is -1, at node number 4 it is +1. Let us go back to the element number 2. Okay, what happens in element number 2? Here it is between 1 and 2, away from node 1, because A1 2 will be +1. Okay, A1 2 will be +1, A then
It
2
to
will
-1.
be -1. Okay, so element number 2 will be, entry will be -1 here, corresponding to row 1 it is +1, corresponding to row 2 it is -1. Okay, similarly element number 3, you check that you can check from here also. Element number 3, this is 3, between 2 and 4. Okay, between 2 and 4. So it will be +1 at row 2, -1 at row 4. Element number 3, +1 at row 2, -1 at row number 4. Then element 4, element number 4 connected to 3 and 1, +1 will be at third row. That means a 3, 4 will be +1, a 1, 4 will be -1. Okay, 3, 4 +1, 1, 4 -1. Okay, -1. Element number 5, you see element number between 2 and 3. So entry will be at second row and fifth row. Okay, second row, fifth column will be +1. Third row, fifth column will be -1. Okay, so for element number 5, second row and third row, because between 2 and 3 it is connected. So away from node 2 +1 towards node 3 -1. Element number 6, similarly you can check it is connected between 4 and 3, away from 4 towards 3. Element number 7, you check it is again connected between 4 and 3, parallel, 2 parallel lines. It is also away from 4 and towards node 3. Okay, so this, therefore you see that once this matrix you can write, I think you can now form this matrix if the graph is available to you. That means if from this network you can draw the network graph and assign directions, arbitrary direction, then from here easily you can actually form this nodal incidence matrix or node to element incidence matrix. Okay, can you form it? Everybody, can you form this matrix? Not clear to you?
Yes, sir.
Okay. Now that here we have considered that the outgoing current, that means if the direction is away from the node, then it will be +1. Direction is towards the node, then it will be -1. This is a convention we are following. Okay, we are following that an outgoing direction will create positive orientation, and incoming direction will be considered negative orientation. That's why it is +1 and -1. Okay, now we see that, say if that graph is not known to you, you know what is the matrix, element matrix, node to element incidence matrix. You see that, then easily you can form the graph. That means once you write this matrix A, once you create this matrix A, you need not henceforth draw the graph any further, or you need not refer to the graph again, because graph is represented in this matrix. Or you can say that basically this matrix is a mathematical representation of the graph. Am I clear? Or this matrix is a mathematical model of the total graph, because this matrix represents the total interconnection and direction of the network, of the graph of the network. Am I clear? Is it clear?
Yes, sir.
Now,
Yes, sir.
okay, now you see what is the column-wise summation of this matrix. If you find the
Zero.
column-wise summation, what is that?
0.
0. Why that is 0? Why the column-wise summation is 0?
তো একটা এলিমেন্ট সবসময় একটা নোডে ঢুকবে আর একটা নোডে বেরোবে।
আরেকটা
হ্যাঁ।
নোট বেরো।
দুটোর মধ্যে কানেক্টেড থাকবে, কোথাও পজিটিভ হলে অন্য একটা নেগেটিভ হবে, and only
Yes.
there will be non-zero entry. All are 0. So except 2 non-zero entries, all are 0. Okay, কেন? Because it has connection with 2 nodes only, and if entry for a particular node will be positive, for the other node it will be negative, so the summation is 0. If, and this is true for each and every column, that means this is true for each and every element of the graph. And since this is known to you, you see that now we can do one thing. What you can do? You can see now, while representing this matrix, node to element incidence matrix, you can actually not write a particular row. You can actually have the, you can take the freedom of not writing one row. Okay, so if you not say, I am not writing this 4th row, I exclude this from the representation. You see that if I exclude this from the representation, am I losing any information at all? If I exclude this, whether I am losing any information at all? Shall I lose any information by not writing?
নো স্যার।
কেন করছি না? Because it is known to me that summation will be 0. তাহলে
Yes, sir.
Yes.
if I do not write or do not represent 4th row, it indicates that fourth row element will be such that the column wise summation will be 0, right? So if this is removed, you can see that summation no longer becomes 0. So obviously I can say
এটা
that
শুধুমাত্র যে ফোর্থ রো এর জন্য, ওটাও তো নয়। এখানে
হ্যাঁ,
মানে যে
যে কোনো রোমের
এই
জন্য
চারটে, হ্যাঁ 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 ওটাই আর কি।
যে কোনোটাকে আমি করতে পারি, কিন্তু কোনো summation loss হচ্ছে না। কেন হচ্ছে না? Because I know that summation will be 0. Okay, and if I, for example, I am taking fourth node, or for example, I am taking first node, first, then you could say that it is summation is +1 means at the first row it was -1. Here summation is -1 means at the first row it was +1. Here summation is 0 means at the first row it was 0. Here summation is 1 means at the first row -1. Here summation is 0, so entry at the first row will be 0. Here summation is 0, entry at the first row will be 0. Here again summation is 0, entry at the first row is 0. So this is known. Any particular row you can remove at will, but generally what we do, if we want to represent the graph with the help of a reduced matrix, that obviously is helpful because that reduces the size of the matrix. Okay, we can take the freedom, we can remove one row, and generally which row is removed? Generally row corresponding to the reference node, because this is node to element incidence matrix. We should later on see that these matrix will be useful to represent the graph, one thing, and this element will be represented to write the network equation as well. So while we write network equation in nodal frame of reference, then we have to choose nodal variables at the variables of the representation. In nodal reference analysis technique, obviously node voltages are considered as variable. How we measure the node voltages? We consider one node as a reference node. So generally the entry or that row corresponding to the reference node will be excluded. Okay, so it is the convention, it is customary to exclude the reference node. Say in this example, if we consider that node 4 is forming the reference node, say here, say this is the reference node, then we shall not include node 4 in the node 2 element incidence matrix. Okay, so generally what to do in the representation of node 2 element incidence matrix, we represent the matrix, we represent the graph using n minus 1 rows, because one row corresponding to the reference node is excluded from the representative, because that node we can afford to exclude without losing any information. Is it clear? Do you understand? You can ask me why you are representing, because we can represent, we can reduce, we can write a reduced form of equation. So if that can be represented by writing a smaller matrix, why shall I write a larger matrix? Because if you consider a large network, this elimination will help you, because it will save the size of the equation, it will reduce the size of the matrix. That will help you. That's why it is customary to eliminate one row, and generally the row corresponding to the reference node will be eliminated. Is it clear to you, everybody? Bolo. Is it clear? So if we remove reference node, you see here, then this is the representation. Okay, this is called the reduced incidence matrix. Should be called reduced incidence matrix, because sometimes if this matrix is given, people call this as the incidence matrix as well. Okay, so by seeing the matrix, you have to understand whether it is a reduced matrix or it is a full matrix. Okay, so basically this is a reduced incidence matrix or reduced node to element incidence matrix. Is it clear? Okay, then we should go to the represent or how this matrix can be utilized. I think now it is better to stop here today, because you have to actually understand how this matrix can be written everybody. What is the property of this matrix? Now you match this matrix with the graph, okay, then I think it will be better for me or for you also to make further discussion on the application of this matrix A, because we shall actually now go to show the application of this matrix A. We shall show how Kirchhoff's current law you can write with the help of this matrix, how you can represent a nodal variable, write an equation to associate nodal variables with the element variable. Okay, that it will be better if I discuss those things in the next class. Before that, you go through this portion. Then otherwise it will be, because we are actually discussing from remote, it would have been much better had we conducted this in the classroom, because in the classroom we can show more examples. We can show, okay, how this is coming, all these things. So it is better if you have that exercise at home, and let us proceed in the next class, not today. Okay, all right. Is it clear? So in that case, we shall discuss the application of node to element incidence matrix in the next class. Similarly, we shall write matrix relating the loop and the element. We shall write matrix relating the Kirch set and the element, and we shall show their application, and then we shall proceed to write network. Okay. Now, if you have any question, tell me. I shall explain that, or otherwise I shall stop today. Okay. Bolo. Do you have any question now?
স্যার
হ্যাঁ
স্যার স্যার
বলো।
আমরা এত গ্রাফ থিওরি সত্যি করে লাগাই কখনো?
হ্যাঁ হ্যাঁ
এটা তো অনেক টাইম কনজিউমিং হয়ে যাবে এত কিছু করে solve
বাট
করতে।
টাইম কনজিউমিং হবে। ধরা যাক you will be writing equation for a large network consisting of say 200 elements or 200 network branches. So can you write the equation of that network? পারা যাবে? Say you have to write loop equation. So it will be time consuming maybe, but if you skip this, you cannot write the equation. Since you have to write the equation, so we have to devote time. It is better that we shall be devoting time and writing equation rather than not being able to writing the equation. Right now?
হ্যাঁ স্যার, হ্যাঁ স্যার।
So obviously this will, and also we have discussed the using graph theory. You will see that if there are mutual coupling, then writing equation or writing nodal equation will be very easy using graph theory. That you cannot do otherwise. So that's why it will be helpful in writing equation, because here writing equation will be following some systematic steps. Those systematic steps, the first step is to draw the network graph, then assigning a direction, then choosing a tree, and then writing the matrix, and then the rest of the thing we shall discuss. Okay, is it clear?
Yes sir.
বলো এবার আর কিছু আছে? আর কারো কোনো প্রশ্ন আছে? Anybody having any question? Okay, then we shall proceed. In the next class, we will continue. Okay. Now let me call your names. Orkaprabhu Mujumdar, Orpon Chati,
Yes, sir.
then Orpon Mondol,
Present, sir.
Orunim Puddar,
Present, sir.
then Oshim Shahu, Binoy Sarkar,
Present, sir.
Debargho Datto, Debargho Datto, আচ্ছা, Debargho Nundi,
Yes, sir.
then Devbanlo Datto,
Yes, sir.